so far? Good, good, good to know. So today we're gonna be Nabila and I are gonna be giving a talk on getting started with building decentralized applications on blockchains. Now, if all of that sounds super complicated, don't worry about it. We're gonna break down every single thing and explain stuff to you. But yeah, so just to start off by introducing myself, I'm Pranav. I'm the director. I'm also the director of founder resources at Startup Shell. We're in a startup incubator on campus. But outside of that, I'm a senior at UMD and studying CS and math. And yeah, primarily have worked on building decentralized applications on Ethereum before in the past. And yeah, that's just a bit about me.
Yeah, hello everyone. My name is Nabila Ibrahim. I'm a sophomore computer science and economics dual degree at the University of Maryland. I am also part of Startup Shell. I'm the co-executive director this semester. And so yeah, I think I got into the crypto space by writing my first smart contract in like April, and we'd love to share our knowledge with you and maybe get your interest so that you start building things on the blockchain as well. So
yeah, so how many of you, can I get a show of hands? How many of you have heard of the word blockchain? Like everyone, sort of. Okay. That's good to know. And how many of you have heard of like Ethereum or Bitcoin? Okay, that's good to know. So today, like, we just want to like sort of primarily go into like what is the blockchain, right? How it works and what it's really used for. And finally, we just don't want to keep this like a general introductory talk. We also want to like show you how you could get started writing your first smart contracts. We'll see if we have the time to actually write one with you all. But yeah, we'll show you how to what a smart contract is, what a wallet is, and how to create your own wallet today. So let's start out with like decentralization, what it is and why it matters. So I'll just swap to just you gotta swap there. Okay. I think yeah. So it's fine. So sorry about it. We got it. Give me a second. Okay, cool. So can you flip it? Yeah. So yeah, so we have an interesting, there's an interesting problem where you have three friends that decide to go out and eat at a restaurant, right? And they both basically somebody paid for the food, and now the three friends, Alice, Bob, and Charlie, need to pay each other for the food, right? So and the issue with them, like Alice just paying Bob, I mean, of course, like you could just Venmo a person and that would be easy, but the issue is, sorry about but so the thing is, like, Alice could only have like let's say she could probably only have like $20 with her, right? I'm sorry, I'm just never used this. I've never used this button before. There we go. A lot of flops happening. It's fine. But yeah, so let's say Alice only has like $20, right? In her account, in her Venmo account or whatever it is, right? And now Alice has to pay Bob, let's say, she has to pay Bob $10, right? But when Alice pays Bob $10, right, her account has to be deducted by $10, right? And if I'm a bank, right, and if I'm hosting accounts for Alice, Bob, and Charlie, I need to know that, okay, hey, Alice knows that that she basically gave $10 to Bob, and Bob also should, there should be some way of Bob to verify that Alice didn't pay $10 when she did not have $10, right? He has to be able to know that that transaction happened, and it happened successfully between three different people, right? And that's basically the idea behind, why so we need some sort of a system where three different people need to, sort of know, how much money everybody has, and the fact that, they're actually doing the transaction. So like Alice can't just be like, oh yeah, I paid you $20 but never paid, Bob $20, right? And if let's say, Alice had to pay Bob and Bob had to pay Charlie Alice's share, right? Like Alice can't just be like, oh yeah, I paid Bob, and then Bob pays Charlie, being like, yeah, I just sent over Alice's money, but Charlie doesn't know that Alice hasn't paid Bob, right? So there's like an interesting problem for which like everybody in this, in this group needs to know, how much everybody has, and what, like, who is doing a transaction with whom, right? Who is paying whom, right? And that's why you need a public database, which sort of, everybody knows is valid and can verify, right? And that's basically like the goal of, like, decentralizing a database, right? So a blockchain is basically just a decentralized database, which is extremely secure. And when I say secure, I mean that everybody has the same copy of the database, right? So every time a transaction happens, right, everybody on the blockchain needs to verify and validate that that transaction is legit, right? So like if Alice is like, I paid Bob $10, right? Firstly, like everybody on the blockchain has to be able to verify that that $10 went out of Alice's account and went to Bob. She has the money, and the transaction successfully happened, right? So and that's where, so a blockchain is basically a chain of blocks where every block contains contains a bunch of transactions. Yeah, switch. So wait. So yeah, so a blockchain is basically something called a ledger, right? A ledger is just like an account book. That's what banks use every single day. And a blockchain is basically a ledger, which stores a bunch of transactions. And the reason it's called, a blockchain is because every block contains a number of transactions. And there's some super complex cryptography that goes into verifying and making sure that all blocks are in sync and they're valid. And this complex cryptography is called consensus. So everybody that's validating that the transactions are real and happening, they're called like nodes that are, maintaining consensus. So you might have heard of, the famous proof of work, which is, extremely environmentally harmful, or like the proof of stake algorithm, which is used by Ethereum or Bitcoin. But that's basically the idea of, like, decentralization, and how it's sort of implemented. And so say what? Yeah.
Okay, so now this is like, why do digital currencies matter? So, you have your Bitcoin, you have Ethereum, things like that. But why does that all matter when you have, like, your US dollar, your cash, right? Why should we switch to, or why should we be using digital currencies? And so imagine, like, let's say you have to fly to another country. So, you have to, like, switch your currencies, get them exchanged. You can't pay like a dollar in, like, Europe or something like that. You have to get it exchanged, right? So having things like, Bitcoin and things like that, first you get instant, low cost, risk-free payments, right? So sometimes when you need to transfer money for like internationally, you have to pay fees, right? That's one thing. Second of all, like, we have a thing where there's a statistic, like in Nigeria, actually 24%, 24.2% of Nigeria uses like Bitcoin because, like, this enables financial freedom and oppressive financial systems, because unfortunately there are places in the world where, sometimes you can't use your money, and like having this global currency, like something like Bitcoin that's like adopted everywhere, can help with that. And also, this is just a global currency, guaranteed transfer, unchallengeable ownership, because, like, as Pranav mentioned, the blockchain tracks ownership, has your transactions, it's immutable, and yeah.
So yeah, so just to add to what Nabila said, right? So Bitcoin blockchain, for example, is the same blockchain that I was explaining about, which basically, contains a list of transactions, keeps a set of accounts, and how much, money those accounts have. But on the Bitcoin blockchain, you can't be, transacting in USD, right? You can't be giving the US dollar to various different people, because, I mean, the US dollar is printed by the Federal Reserves and maintained by the Federal Reserves. So instead, you have Bitcoin, which is a cryptocurrency that's sort of sent between various different accounts. And the beauty about Bitcoin is the price of Bitcoin is basically maintained by like, the number of times people are buying and selling it. But more than just the price of Bitcoin, the beauty about this system is that even if a government shuts down, right, Bitcoin will always, be a currency that you can use. The reason is because you have like over 1 million different, people keeping copies of this blockchain of like, this ledger of all these transactions, and you have like millions of people validating whether every transaction is valid. So even if like, let's say the US government shuts down tomorrow, which touch wood, hopefully it doesn't, you can sort of, the beauty is that, like these nodes will always, maintain consensus and make sure that, your transactions go through. So in, especially like, where you have, you have financially, you have countries which have like, oppressive financial systems, or like unstable banks, like cryptocurrencies are really, really helpful over there, because primarily because you don't have to rely on your government to maintain the value of your currency. But Bitcoin's not great. And the reason it's not great is primarily the reason it's not great is because it's a very old blockchain. Bitcoin, I believe, like the paper was published in 2013 or something like that, or 2008. Okay, I might be wrong. But the thing is that it's very slow and very expensive. So every time, let's say I send money on the Bitcoin blockchain, right? To do this consensus, right? Like they're not doing it for free. I need to pay these people to validate that my transaction is real. And that's basically a transaction fee that goes through. So for example, if you have ever, done like a wire transfer from a bank, for example, right? They always charge you a transaction fee that's required for like, the bank to facilitate the transaction, right? So the Bitcoin's transaction fee is really high, primarily because it can process very few transactions. And if there are multiple people, trying to like process the same, like trying to, more people are trying to, process transactions, but it can only take like 5 transactions per second, then your prices for each transaction is just going to go up. So it's very expensive because, the demand to, pay people in Bitcoin and pay for things, using Bitcoin has obviously, shot up, and it's extremely, slow and inefficient. So it's a decent blockchain, but it's also like not very useful for a lot of things we do today. So drum roll, please. Enter Ethereum. Ethereum is a newer blockchain. I believe the paper was first published in 2013. I might be wrong again. But the reason Ethereum when Ethereum came in, it was a lot more better, was because it was a lot more efficient. It can process a lot more transactions per second, right? And which means that the cost of transactions also goes down, right? So like every time I send money to Nabila, I don't have to pay like $10. I can pay a lot lesser, when I'm using Ethereum, right? But one additional thing that Ethereum added was you could write programs on a decentralized system, right? And you might be asking yourself, why should I do that? I mean, if I can write, a Python program on my own computer, there's honestly no point in me doing this on like, 100 different computers. But it is actually useful in a lot of applications, and you'd be quite surprised. So for example, every time you write a program on the Ethereum blockchain, right? Every time you run that program, it's running on like 200 different computers, and all of them are verifying that it got the same output. So running it on this, although might be way more inefficient than running it on your own computer, the beauty about this is that all those computers are validating that, the program ran the way it should have run, and like there's no malicious code going in there. There's none of that stuff's happening. So I think I'll hand over the mic to Nabila to talk more about. But why don't you just give them a brief about like smart contracts?
Yeah, in the slide, like. Okay, yeah. So now how Pranav mentioned, there is like a way to, I guess, deploy applications on the blockchain. And these are basically called smart contracts. And smart contracts are secure, decentralized protocols that run on the blockchain. And basically, like Brenna said, when you know, oh, sorry. Yeah. So basically, smart contracts are programs you can run on the blockchain. And when you deploy a smart contract, it's validated by like all the computers that are hosting like, these copies of the blockchain on it. So you can validate, like Pranav said, you're not, like someone's not deploying like malicious code that can like hurt other people. So in terms of like how to, yeah, in terms of like, okay, now how do I write a smart contract? Like, I can write a smart, like a Python script on my computer, run it, maybe like host it somewhere, deploy it. But like, how do I do this with like, the blockchain, right? So next slide. So basically, there are many ways to write a smart contract, but one thing we'll be going over is Solidity, which is a language that you can write smart contracts on for like Ethereum and Polygon, two different blockchains. We talked about Ethereum a bit, and Polygon's like a level above Ethereum, which is like it optimizes like transaction fees and things. But the thing is like, okay, so here we have a basic smart contract written in Solidity, and if you like, who here has ever written JavaScript or like knows about it? Cool. So does this look like maybe a bit familiar to you? Yeah, sort of. Yeah. So well, actually, for me personally, like I knew a bit of JavaScript and I was like, oh, okay, this kind of makes sense. But to basically go over what the smart contract does. So the smart contract is basically giving you the ability to update a variable, like unsigned int variable called count. Basically just increment it, decrement it, and then get the value. So like if we could just run through the code. Oh, you see that mouse? Okay, cool. So the first thing is just like, you import your version of Solidity, right? And then over here you have uint public count. So this is basically saying this is an unsigned int. If you guys know unsigned int, it's basically a positive integer. I believe it includes 0 as well. And then it's 32 bits. So you'd get like a bunch of values inside there. It's public, so it can be used like throughout the program, also being accessed outside the program. This is basically access modifier. If you guys did like Java, you'd be a bit familiar with that. Yeah. Okay. Okay. So the first function is your get function. So you can just basically return the value of count. So it says just return count over here. If you ever need to get that value, you can call this function. You have a second function called increment, which would just increment the variable of count by 1. And then the second one is decrement, which decreases it by 1. So this is a very simple smart contract. If you want to deploy this, and then you can call these functions and just change the variable around. So yeah, that's a basic contract.
Right. And so yeah, I mean, so just to clarify, so what she showed there was, like a program which you can deploy on the Ethereum blockchain. And every time you run that and you run a count function, I mean, it would be quite useless to run that program, because I mean, there's no sense to like run like a counter program on like 100 different computers and verify results. Like, not very useful, and it's expensive and inefficient. But the other advantage that comes with smart contract, because the blockchain is this public, decentralized database, is you can also, like, a lot of these programs that you deploy on Ethereum, anybody can publicly view them, right? So if somebody is like sort of like, running this particular program, that does, for example, a counter, anybody can see what value it counted, or like how the function works, or where it is, just to make sure there's no malicious code. Because today you could have like like a Python program, right? And the Python program could like install malware on your computer, and you might not even, there are ways to like prevent, like not even know what's happening in there. But like on these kinds of programs, everybody can verify and validate that these programs are completely secure. And what that lets you do is that lets you now write programs that could let you facilitate money payments and transactions, right? Because it's public, because it's secure, because it's viewable by anybody and everybody. What this lets you do is I can now write programs that will, let's say there are 3 people, Alice, Bob, and Charlie, right? And Alice wants to pay Bob 30% of any money that she sends, and wants to pay 50% of like, any money that she sends to Charlie and Bob separately. You can write that in a program, right? Just like you would in a normal Python program. And you can pay that all, right? So the cool part is that not only can you write simple programs, you can also like facilitate doing financial transactions through programs on the blockchain. So that's why it is so amazing as a technology. Yeah, sure.
Yeah, okay, so this is yeah, so like Brian was saying, like now let's get into like, you know, a bit of a more complex smart contract, like better than the counter one. But this basically smart contract kind of mimics like a wallet. And like Brian said, a wallet is basically your Ethereum wallet or your crypto wallet, something that can store like, you know, any cryptocurrencies you have, or, you know, any NFTs you own or things like that. It's like, you know, you have your physical wallet that holds your money. Now you have your digital wallet that holds your digitized assets. So if you went through this one right now, so this is just a constructor that, you know, creates the owner of the wallet, right? And then so just look at these two functions, withdraw and get balance. So if you can see withdraw the function, so it's like it takes in a parameter called amount. So, you know, how much do you want to withdraw from this crypto or this wallet, right? And if you see this, the second line over here is really nice because at some point now, since this is like a public contract, you know, at some point anyone can access these functions, right? But this shouldn't be that like anyone can withdraw money from your wallet, right? That wouldn't be great. You know, if someone's taking your money, be like, oh my goodness, all my money's gone. Right. So basically this line over here, it's like require message.sender is equal to owner. So basically we're having a check here, and this is like a nice thing in Solidity. You can like have a check. So message sender is basically the person who's calling this function, and we're checking if their address is the same as the owner's, right? And if that's the case, then you can like transfer this amount out of the wallet. If it's not the case, then this like this function is just like, oh, you're not the owner, you can't call this function. And the second thing is just getting the balance of the wallet. This is an external function. So in this simple implementation, everyone can view your the balance in your wallet. That's very interesting. But yeah.
So just coming back to the example I gave you of like Alice, Bob, and Charlie, right? And they're like, Alice wants to pay Bob 30% of any money that she sends to this contract, and wants to pay Bob, you know, the rest 70%. I think I said 30 and 50, and that doesn't make sense. But no, I mean, but over here, what you can see, and as Nabila was explaining, the amazing part is that because everybody can see this contract and run this contract, you don't want, you know, like Bob to be running this contract and stealing money from Alice, right? That's not what we want. So there are ways to like verify that, you know, Alice is the person running this contract, and for that, you know, you have so how do like accounts really work on the blockchain, right? And for that, you have something called wallets, right? Wallets are basically they're just, think of them as accounts that can store money, right? But the thing about wallets on the blockchain is they're not a traditional account like you would open in a bank, right? Because in a bank you would have to give your social security number, you'd have to give utility bills and whatnot to open a bank account, and the government would have to verify that, you know, that you can hold a bank account in the country. But on the blockchain, the beauty about this is that anybody can create a wallet, and the way it works is a wallet is basically a public and private keeper. So it uses some extremely complex, complex and actually amazing cryptography today to basically, have to create this thing called a public-private keeper. Now, a public-private keeper is the idea of it is where you have like, you know, somebody has a digital identifier that they can send to, you know, somebody else to send them money, as well as they also have a private key, you know, to be able to sort of, you know, approve of stuff. So for example, you know, if we come back to the Alice, Bob, and Charlie example, you know, if Alice wants to send money to Bob, Alice would need some kind of identifier for Bob, right? So some kind of account number. But at the same time, Alice should not be able to steal money out of Bob's account, right? So, and that's why you need public and private keys. So a private key is something that you keep yourself and nobody else knows about. But your public key is something that anybody can see. So if you actually look at a lot of people that use, you know, cryptocurrencies on Twitter, you'll see that they put their public key out on Twitter. And the reason they do that is because anybody in the world can access it, and anybody in the world can send money to it. But nobody could, you know, just have your public key and forge stuff, by you. So they would need your private key. for that. And that's how they do identifiers.
Oh yeah. So also, and coming back to like, how Pranav gave the example of Alice, Bob, and Charlie, and like the decentralized aspect, like, how can like, Alex can just tell Bob like, I paid you money, like, and then like Bob will be like, oh, I didn't get the money, and then Charlie's like waiting for his money, and then like, you don't have that thing keeping track of all this. And like I said, this contract, right, it's public on the blockchain, everyone can see, but also these transactions that people make, these functions they're calling, this is all like being noted down, right? So basically now, like with this, like if they start paying each other like using this smart contract, we can be like, okay, so Alice transferred this money to Bob, and then Bob transferred this much to Charlie, and then they can all be happy that they all got their money.
And so the beauty about about being able to run smart contracts on or these programs on the blockchain is that everybody can now see stuff, right? So they can read all your smart contracts, see all your code, and see how it's being executed, right? To make sure there's no funny business going on with running your programs. So we look at the history of the web, right? The internet as we see it. You had in the 1980s, when you had the internet, I mean the web that came out. You had Web 1, which was like newspapers like the New York Times or any of these newspapers just publish content, and people could read news. But the issue is you couldn't interact with it, right? And yes, I'm not talking about likes and stuff like that. I'm just saying that there was no way to write on top of it. They were just like serving like static content that never changed. And then came Web 2, right, in the 2000s. And the amazing part about Web 2 is you could read and write onto a web page. So for example, using if we look at Twitter is a great example where, or like Instagram, right? Whenever you upload a picture and submit it, you're writing data to like some database, right, sitting somewhere else. So but the issue is that with the amazing part about you can't really run, let's say write something or like read something and make you need a way to be able to like execute something to that and to tell everybody in the world that you sort of wrote some data to this piece of this database. You need some way to show people that everything you did is like publicly accessible and so that they can sort of like trust you. And there are applications for this that we'll go into very soon. So yeah, so again, so as just looking at into what the applications of blockchain that are really, really cool is one which is asset digitalization. So with cryptocurrencies, right, that run on these blockchains, you now have digital currencies. So you don't have the US dollar anymore. So people can now do payments with cryptocurrencies. It's way more efficient because you don't have middle banks that are like sort of processing your transactions. You don't have Visa and MasterCard, none of that stuff happening, because it's all happening in a completely decentralized manner. You also have a digital identity, right? Because you have a wallet, right? You have a public key that is universally unique. So nobody else that creates a wallet will end up getting the same public key that you do. And again, this is because of the cryptography that we've been working on for years and years up until now. And finally is the new era of computing, right? So the amazing part about this is now you can run programs on the blockchain and everybody can see how they were run, what is happening in those programs. And Nabila will cover like applications of like NFTs, how they work, and like why they're why Web3 and just blockchains help us conduct NFT transactions and stuff like that. So before we get to questions, let's just okay. You want to talk about like NFTs and how they sort of work?
So okay, just curious, who over here knows what an NFT is? Okay, cool. I mean, some people, that's great. So NFT basically stands for non-fungible token. And what this basically is like, okay, let's imagine you have like $1, right? And you can trade $1 with another dollar, right? So that makes it fungible, right? It's tradable, the value is the same, right? But when you come into like non-fungible things, these are two things that cannot be traded with one another. So like if you imagine like, you have like art pieces, like, every art piece has its own story, its own creator, different values, and they're non-fungible. Like you can't trade them. So right now you have like NFTs, which are non-fungible tokens, and like right now they're being used a lot as like, digital art. People are, like publishing art pieces as NFTs, right? So in terms of NFTs right now, they're like a smart contract on the blockchain. So what it is like, someone can mint an NFT to the blockchain, like they create one, they can mint it to the blockchain, right? And they own it. But then you can also have like different, like you can compare it to like, Bitcoin, like, it's another token you own, right? And then you can basically like transfer that to someone else's wallet, and then they can own it, and then they can sell it to someone else. And basically generally like, your NFTs are sold on like, marketplaces like OpenSea and things like that. So if you're interested, but yeah, talk about like ERC20. Yeah, okay. So
I just wanna sort of like just add to that, saying that, so basically, as I mentioned that, a blockchain is a public database, right? So one thing that it's good at is, storing financial transactions, but it's also good at storing state, right? And what I mean by state is if somebody, buys a piece of art, let's say it's an NFT, right? What it's good at doing is like the program is good at storing that your wallet owns that particular, the JPEG, for example, right? And the amazing part is because it can store state, and because it's publicly accessible, anybody in the world can view that you own that NFT because it's associated with your wallet address, and it's on this public database that everybody can see. Yeah. So, but yeah.
I guess we can talk about ERC.
Do we want to talk about questions?
Actually, do you guys have any, like, as of now, do you guys have any questions? Like, yeah. So. Yeah. So actually, we're gonna get into showing some programs. Yeah.
We can. Yeah, we'll jump into that. We just wanted to see if there were some theoretical questions on like the concepts that we just spoke about. Yeah, go on. So, so firstly, like Bitcoin, I believe there are ways to run these smart contracts or programs on the Bitcoin blockchain, but I don't. And so I think so. So the one issue is basically like to be able to support smart contracts running on the Bitcoin blockchain, you have to update your, the people, the nodes that are running on your validator network to be able to support running, these smart contracts, right? And because the Bitcoin blockchain is so old and like the developer community is like so like elitist, they don't really want to, update it to support, a lot more transactions and make it much faster. But the Ethereum blockchain, for example, I mean, they were built with smart contracts. The goal of having smart contracts when from the ground up, right? So that's the main reason why it does support smart contracts. But regarding transactions per second and why it's so slow, it's primarily because I just think I believe it's because of the consensus algorithm that it currently uses. It uses something called proof of work, but that we'll be getting into a lot of technicalities, which I don't really want to get into. So, but yeah, I mean, if there are no other questions, then there's one here. Yeah. Yeah. Right. No, great question. So every blockchain is designed differently. So for example, on the Solana blockchain, you have to have like a copy of the whole blockchain, or like you have to have like a major chunk of it or something like that. So you have to have a really beefy validator, like it has to have 64 gigs of RAM and stuff like that. But but like on Ethereum, I believe they have like some concept of like keeping only a part of it, a part of the blockchain. I've not really done, I've not really done too much research on hosting my own validator. I've run a Bitcoin miner before to just understand how it works. But yeah, I mean, there are ways of like, so a lot of the blockchains, so for example, like on the so a lot of the times when you're running a validator, you're usually running it in a pool, which is like something that has its own network and sort of like collecting resources from different computers. And the amazing part of that about that is like, you don't need access to like, really big machines to store infinite size of stuff. Yeah.
So you could say yes, interactions at some point can be anonymous, because right now when you see transactions on the blockchain, you only get someone's like wallet address, right? Their Ethereum address. So if you don't know what address, like who owns that address, at some point it is anonymized. But the idea is it's anonymized in a way that like you still know who's doing it in terms of which wallet this transaction is happening from, but like this is not really connected to like at some point a social identity.
So I want to also add that, I mean, so the beauty about having your own public key, your cryptographic key, is that, nobody associates your name, your address, or your identity with it. However, I mean, you might have seen places where like people are able to reveal who the person is that, ran like some scam on the blockchain, right? And in those cases, yes, I mean, you can trace, because it's public in nature, you can trace everything, but there are blockchains that have come out recently that sort of try to, increase anonymity. And I'll be happy to discuss that with you if you have any other questions. Please go. Right. Great question. So so remember I mentioned that the blockchain is like a great state machine, right? Which means that so if you've ever like have you written Python before by any chance? So like, how like you can assign a variable to like, let's say, or a list to like, some particular with a list of strings, for example, right? You can assign a variable to a list of strings. Now think about doing that, but on a public like a public system where you can keep track of every time you run, assigning that variable. So so for example, like if we just look at like NFTs, right? So every time I mint an NFT, or minting is basically creating an NFT, what I'm doing is I'm just updating that Python list, but running on this public system, right? And so that's how like so blockchain supports these things like NFTs, and because of this, it sort of supports things like for example, the best example people keep talking about is the metaverse, and like how you can like store like immute, like how you can store like artwork in there that stays there forever. And the way they do that is using like NFTs. I mean, like when everybody talks, Web3 and blockchain are like very, very hot terms. And I mean, it's because I mean, NFTs are really cool in terms of like how they work as a technology solution. But again, we're not at the stage where, like every single thing is, running on Web3, or like, yeah. So I don't know if I answered your question. Okay, cool.
Okay, cool. So I guess we should talk a bit about like applied blockchain. So what are some implementations? So right now over here, this is called ERC20 token. Basically in Ethereum, actually this is like Open Zeppelin's like implementation, but let's say you want to make your own cryptocurrency, because why not, right? Sometimes people want to make their own cryptocurrency, but so there's like a really nice implementation and standard. Like if you guys ever heard of like an interface in Java, have you heard of an interface in Java? Few people. Okay. What an interface is basically, it gives like a skeleton implementation. You call it like a list of methods that something would need to, implement so that it could, fall under the standard. And basically that's what ERC20 token is. It's like an interface in like Solidity. And what it does is it gives like the kind of, structure you should have when you create your own cryptocurrency. So if you can kind of just like run through this, you have like a name. So every cryptocurrency has a name. You have like a symbol. Like Ethereum is ETH, right? You have like the decimals. So the amount of like, oh, this is a bit like, well, I mean, yeah, you can send like 0.00001 Bitcoin, like you can go till like 18 decimal places, but or Ethereum, right? And then total supply, like, okay, how much, what's the total supply of this whole cryptocurrency? You should be able to get that. You should be able to get the balance of like a specific person who owns a wallet. You should be able to transfer like, this cryptocurrency, and you should be able to like transfer from this address to that address. So like basically just a few methods that you can use to implement successfully, like the bare bones about a method you can use to implement, like successfully implement like your own cryptocurrency. Hold up. So actually, now I know someone asked about like our own projects and things like that, and I wanted to share something with you guys. So now I also said like, why would someone create their own cryptocurrency? I actually did. So yeah, like my friend and I mentioned, we're a part of Startup Shell, and we're like an entrepreneurship incubator on campus. And we were just thinking, like, wouldn't it be so cool to have our own cryptocurrency to do like internal transactions and like reward members for community engagement? So what we did was we implemented an ERC20 like we imported the Open Zeppelin ERC20 contract to kind of build our own cryptocurrency off of it. And this is like a lot of code, but I can run through it pretty quickly. But yeah, oh yeah, Open Zeppelin is basically, I'd say like their organization who, like puts out like a lot of implementations of like, different things you can do on the blockchain. Like they have their, like there's something called ERC 721, which is the standard for creating your own NFT. They have ERC 20, which is for like cryptocurrencies, and they have like many things, and they're like a great thing. You should probably search, like you can search them up after this talk to kind of see what else they have. They have like a really nice GitHub with like all the smart contracts they have. But yeah, to just go a bit over this, we call this Shellcoin, and I was like a high level overview. So right now, like I guess. So so I can give you like a high level overview of what we were thinking about this. So initially we're like, okay, we should have a cryptocurrency. You should be able to like mint more tokens, and you should be able to like, members should be able to transfer it to one another, get the balance and things like that. But we're like, what would be so cool is like, let's say we have, owners of this cryptocurrency. So there's a, you're not going to
No.
Okay, yeah, no, it was like, so we basically, how we implemented this is like, we have 5 owners, and like they're like kind of like the, I guess you say owners of these cryptocurrencies, kind of managing everyone. And we have one, and basically they kind of, and I can kind of go into like what they do, but we have a validator, which is able to like validate people and like mint coin to them. So that's basically, you have like a list of owners, we have 5, and then you have like a validator, and then we store some variables like, mapping your addresses to if they're an owner or not, and things like that. But just at a high level overview. So over here we have like a constructor. We basically take in the owners and the validators, and then we create Shellcoin by like, passing this name Shellcoin, your token name. And then, so we mint the initial supply, and then we make the owners actually like stored as owners over here. But yeah, okay, so to go into the functionality. So the first functionality we have is like send coin. So we're actually just directly like minting. So we have like, first we require the message sender to be an owner or a validator. Sorry, like, so no one else should be able to send coin unless they're a validator, because we should not have people just minting unlimited coin to their own wallet, because that just like devalues the currency, and also that's just bad. But yeah, so we require like the message sender to be the validator. Okay, now if they're the validator, then they can mint the like this amount of coin that we pass in to the account, right? And then yeah, so this is the way you can send coin to someone, or the validator can send coin to someone. Another thing is remove coin. Now let's say someone's being a bad actor, they're misusing their currency, or I don't know, they're not acting good, and then we're like, okay, so burn is basically a method that takes out like all the coin from their wallet in terms of like Shellcoin, right? So basically we'd say, okay, is this an owner? So this is like a specific functionality an owner can do, and if it's an owner, then they can like burn the thing.
Yeah,
but yeah.
I just wanna add that burn is not like some malicious function. It has valid use cases. So the best use case of this is that if you have like too much of one token, right? And what happens, like let's say there's too much of Ethereum that exists in the world. I mean, the supply increases and the demand remains the same. So the price of every Ethereum is gonna drop. This is not the case for it. I mean, I don't think you can do this for Ethereum, but like in the cases if Shellcoin, increases in value, and you want to burn it to decrease the supply, you would do this.
I think also, to give a real world example, like from an economic perspective, if when we're in inflation right now, a lot of times when we're in inflation, the Federal Reserve, who controls the money supply, sometimes cuts down the money supply. They don't burn the money, but they just, take it out of the system. They tax people to get back the money, and they pull it out. This is actually like economically used in our world, and this is just like an implementation on the blockchain. So okay, the second thing, another function we had. So a lot of this thing, so ERC20, what it's basically doing is we're implementing ERC20, and that's handling all the things to like transfer money, to like, get the balance of people's wallets and things like that. And like the additional things I wrote was just kind of to manage the system of like having 5 owners and like a validator to like properly send money. So if you guys are interested, I can kind of go into like more things. It's just like confirm someone's an owner, or actually this is confirmed, like this is like we have a voting system to like make like decisions so that like, for example, we want to update an owner, so we have to have like a consensus between all of the owners to add a new one. We want to update like the validator, we have to do that as well. So this is just like a bunch of methods to do that. But yeah, this is basically just implementing the ERC20 token to like handle like, just having that, standardized, like, how should you, get the balance, send the money, do things like that. And this is just like an extra implementation.
Yeah, and so that was basically like, an example of like how a smart contract's written and how it looks, and Nabila is actually a really good at writing smart contracts. But basically, now we're sort of gonna show you like something that we. Okay, you wanna talk about it? What you're showing? Oh, sure. What? Oh, okay. So no, I thought you're okay. Cool. It's fine. I can. It's fine. Okay. So yeah. So basically, this is just this is another example of an NFT smart contract. So you might have heard of NFTs as JPEGs, and they're sort of not wrong. I mean, they are technically JPEGs, but just go to the. It's fine. You don't have to. Yeah, it's fine. Yeah, so as you can see, we're basically pulling in, some kind of a skeleton from this thing called Open Zeppelin, as Nabila showed you. And as I mentioned, the blockchain is a state machine. So every time somebody gets gets an NFT, what's happening is it's mapping the NFT token, which is like a number 1 to or 1, 2, 3, or 4, to like an address, right? And the address is, your public key or your universally unique identifier, right? And then basically every token also gets mapped to a metadata, and the metadata is basically, the JPEG or the URL of the JPEG, which is accessible, right? And so the great part about this is anybody, in the world can see, where what like your address is mapping to, what like, JPEG URL it's mapping to. So yeah, anyways, but there are a couple of functions in here. First is like minting an NFT, right? So so this is how you would, if I wanted to create an NFT and send it to Nubila, for example, I could just run this, call this function, and it will run on the blockchain. I pay a transaction fee to run it. And what this function will do is, you can see it'll basically update that state of that mapping that I showed you right over here. It'll update it to Nabila's address that I'm sort of putting it in, and it'll update the token metadata, which will be like the JPEG URL, right? And yes, this is a very simplistic smart contract that just supports like minting NFTs, and yeah, and that's sort of how it works. I think finally, yes, I think we're sort of running short on time, so I guess we primarily, yeah. So
okay, so now I just want to say, please hold up. Can you present this? Oh, bro. Okay, it's okay. Well, okay, so now you have some basic understanding of what the blockchain is, what cryptocurrencies are. Maybe you saw a few like examples of how you can write your own like smart contracts on the blockchain. So what are some next steps? So basically, one thing you can do is there's like a really nice course on crypto zombies, which is basically they give like a really nice course on how to like write smart contracts in Solidity. So that's something like if you're interested in like learning from the basics, that's how I learned. I'll personally say the smart contract I showed you with like Shellcoin, I think it was like over 2 days of I did a bit crypto zombies and then I just started writing. So it's like very easy to catch on if you know a bit of JavaScript. I really like Solidity because like, like I don't know, I really like the syntax and I think it's pretty easy to catch on. So definitely recommend crypto zombies. Also, we had like one of our fellow Shell members make a Bitcoin playlist. If you guys want to scan that, it has like really good videos about like, the blockchain, some good concepts and things like that, easy to understand. I know we do have a few minutes, so yeah, I wanted to show. So we actually. Oh wait, are we still sharing our screen?
Just share your whole screen.
Okay, we're sharing. Okay, wait, how do you escape? Okay, so actually, I just want to share something. So Pranav and I and one other person have been working. Oh yeah, you had a question? Oh yeah, Pranav and I and one of our friends were working on a project called DeFi Swag, and the idea behind it was that we were making an e-commerce platform for people to buy, merchandise with the NFTs they own on it. And it's like, right now your NFTs are on the blockchain, they're hosted on a URL, like, Pranav showed you, but like, there's no good way to like physically display ownership of your NFTs. So like, we're basically enabling that through like helping people like print shirts or hoodies with their NFTs on it. We actually deployed our website today. So I just want to like show you guys. Attack. So you guys see here, this is what I was working on with like Pranav and our friend like over the summer. So what you can do is you can just like, so there's one thing called an ENS domain. And that's basically like, you know how you have your domains like google.com or like something else, right? But now you can also have domains for your wallet. So instead of having your like really long crypto like your wallet address, like, you see this, you can just have like something.eth. So our friend had like enjc.eth. And what this basically does is like, okay, so you can go and you press explore, and then we use this API. It's loading. Yeah, we use this API called Alchemy, and what it do is like it give you all your NFTs, so you can just kind of run through like NFTs, and then like let's say select this, and then what it do is it kind of show you how it looks on like hoodie, right? And you can kind of see, and then just like pick a size, buy now. But actually, I don't own this wallet, so this has something on the side where you need to verify that you own the wallet you're trying to buy an NFT from, because I shouldn't be able to buy a hoodie with your NFT on it. So we basically, the rest of the website just verifies that you own that wallet address, takes you to Stripe for checkout, and then you can buy an NFT. So if you guys are interested in like, if you guys want to talk to us after like how to mint your own NFT, things like that, maybe buy some DeFi swag from us, like, yeah, come to us after the talk, and we'd love to like talk more about it with you. So yeah, thank you so much.
Yeah, if you want to make a Technica hack on and building a decentralized application, come to us. We'll be happy to talk to you. Thank you all for coming.